Chapter 18, we start looking at probability and some terminology to define our sample space, experimental probability, and theoretical probability. Experimental probability implies that we're performing an experiment and our probability is based on the outcomes of those trials. Theoretical probability is based off of the different ways that something possibly could happen and the different possibilities for success. A tree diagram is one way of looking at a sample space and probabilities. And we're going to start by flipping two coins. We have two events here. One event is flipping one coin, and we can either get heads or we can get tails. And then after that, we have two possible outcomes for the second flip. We could either have tails after getting heads, or we can get heads after getting heads, and tails and heads on the second option. So our sample space is heads and heads, heads and tails, tails and tails, tails and heads. There are 4 items in the sample space. Now we're drawing 2 marbles from a bag that contain many red, green, and yellow marbles. This is what the tree diagram for the outcomes would look like. The sample space is going to contain 9 items. Red, 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 green, red, yellow, green, red, green, 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 yellow, and yellow, red, yellow, green, yellow, yellow. And we get those just by walking down each one of these branches. Red, and then yellow. Green, and then red. Those are 2 things that are in the sample space. The probability of picking a green out of this arrangement. Probability of getting a green, there are 12 possible outcomes, 3 of which would be considered successes. Our probability of picking a green is 1/4. The probability of picking green or an orange. There's 12 outcomes, and the number of ways we could pick a green or an orange are 3 plus 5. So this would be 8/12, which is 2/3. The probability of picking the complement of green, or the probability of not green, well, there are 12 possibilities for our pick, and there are 9 things that are not green. The probability of not picking green is 3/4. One thing to know about an event and its complement, green and not green, is their probabilities will always add up to 1. Independent and dependent events. Independent events are where one event has no effect on the likelihood of another event happening. Dependent events, one event does affect the other one. And we'll look at some examples as what this is. And one thing we need to make sure we understand is that and this event happening implies that we multiply, or implies that we do addition, like with picking the red or the green, or orange or green it was. We added those number of ways it can happen. So I want the probability of flipping heads on a coin and rolling 6 on a die. These 2 things do not affect each other. What I get on the coin doesn't affect what I can roll. So the probability of getting heads and a 6, probability of getting a heads is 1/2, times the probability of getting a 6 is 1/6. So the probability of both events happening is 1/12. Here we have 5 red items and 4 green. I want the probability of picking 2 red with replacement. So there are 9 possible things, and there are 5 reds to pick out of those 9. So the probability of picking a red is 5/9. Now I put that item back. So for the second pick, there are still 9 things total. There are still 5 red ones. The probability has not changed from one pick to the next. So this is These are independent events, these two picks. Our probability is 25 over 81. In the second one, we're picking 2 red without replacement. So the first pick, there are still 5 red out of 9, but on the second pick, the probability changes. There's 8 things total, 4 of which are red. We're going to have 20 over 72, which reduces to 5 over 18. Here, the second pick's probability got changed because of what happened on the first one. These two picks are dependent on each other. In this example, the probability that a car starts is 80%. The probability that a motorcycle starts is 60%. We're going to use a tree diagram to find these two probabilities. One event is that the car starts. The other possibility for the first event is that the car doesn't start. I'll call that car broken. The second event is the motorcycle. And the motorcycle can either start or the motorcycle can be broken. And what we can do now is we can fill in probabilities on these branches. The probability that the car starts is 80%. Therefore, the probability that it doesn't start, its complement, is 20%. Probability that the motorcycle starts is 60%, and that it's broken would be 40%. And same thing on this other set of branches. Now the probability that they both start, that means we want to go down this branch. We want the car to start, and we want the motorcycle to start. So for A, we're going to do 0.8 times 0.6. For B, the probability that the motorcycle doesn't start, this can actually happen in 2 ways. The car can start and the motorcycle can be broken, or the car cannot start and the motorcycle's broken. So in this probability for B, we're going to do 0.8 times 0.4 plus, because there's a second option, or 0.2 times 0.4. Here we have 2 bags. In each bag there are, in one of the bags there's 3 red and 2 green. In the other bag there's 1 red and 4 green. I'm going to pick 1 ticket out of a bag, and that bag is going to be decided on by flipping a coin, and I want to know the probability of getting a green. We can use a tree diagram to decide this. So we're either going to pick A or B, and within bag A we're going to pick a red or we're going to pick a green. Or within bag B we're either going to pick a red or we're going to pick a green. The probability of picking bag A is 1/2, same with bag B because we're flipping a coin to choose. Now within bag A, the probability of picking a red is 3/5, while the probability of picking a green is 2/5. In bag B, the probability of picking a red is 1/5, and the green is 4/5. Now I have to look at the different ways that I could end up picking a green. I could pick a green out of bag 1, out of bag A, that would be this path. Or I could pick a green out of bag B, which would be that path. So my probability is going to be 1/2 times 2/5 plus 1/2 times 4/5.